Hey students, it's Mr. Woodward. In this video, we're going to be talking about graphing motion in different views, three views in particular: a position view, velocity view, and acceleration view. And so I want you to think about the experience of going to an event, maybe a basketball game, and seeing that event from different views. So you could be in courtside seats, seeing the game from the ground level up close with lots of detail. You could be higher up, maybe at like half court, a few rows back, where you get to see the whole game, but like not as much detail on the players' faces. And then maybe you've got some nosebleed seat that you could be in, where you can generally see what's going on, but the level of detail is not at all what it would be if you had courtside seats. And that's kind of what these graphs are showing in position, velocity, and acceleration. Is they all show the same event from totally accurate perspectives, but the level of detail that each one is showing is different, and it goes down as we kind of come higher up in the view. So we're going to start with our first view of some motion event. It could be tracking the motion of a basketball as it's shot from somebody's hand to a basket, or tracking the motion of a car that's accelerating, or whatever. And the first view is position versus time view right here. So in position versus time view, a graph is showing the position on the y-axis, and it's showing time on the x-axis. And so in this first graph, the type of motion is constant velocity. So we're imagining an object that's moving at constant velocity, and it's moving in the positive direction. So what would that look like if we were just tracking the position versus time? Well, it means that the object, let's say the object is starting at a position of 0, and if it's moving in the positive direction at constant velocity, then the increase in position would just be like constant over time. And so you just get this straight line up and to the right. If it was moving at constant velocity in the negative direction, well then maybe the position is going to start up here. And if it's moving in the negative direction, then the position is approaching 0. And so as time goes on, the shape of the graph would look like that. So this is still time. This is still position. What if it was speeding up? Well, if it was speeding up over here, you would still see an up and to the right trend, but now the steepness of the line would increase, because it would be covering more distance in less time. And in fact, on a graph like this, if you ever saw a slope where it went like straight up, that would be like infinite speed, right? Because it would be in like a ton of different positions within a very short period of time. So it'd be going really, really fast. If it's slowing down, then you would see the curve go the other way. I'm sorry. If it's speeding up in the negative direction, you would see the curve go the other way. So now the slope is getting steeper and steeper and steeper. Here's my struggling here. Here's my slope, right? Slope is getting steeper and steeper and steeper, but they are negative slopes. These over here are positive slopes. Okay, so speeding up in the positive direction or speeding up in the negative direction. Either way, the slope is increasing. It's just in one, it's increasing in the positive direction over here, and in the other, it's increasing in the negative direction over here. Okay, what if your object was slowing down? Okay, if it's slowing down, it's going to start off at a relatively quick speed, and then it's going to flatten out, because a flat line means constant position, right? If the position stayed here over time. And constant position means that something has come to a stop, right? It's not changing its position. So as the line approaches flatness, it approaches a resting position. What if it was slowing down in the negative direction? That means it would start moving in the negative direction, and then it would similarly approach flatness, slowing down in the negative direction. And what does it look like if an object is at rest? It means that it is constant position, right? And that could be here, it could be up here, it could be down here. All of those are options, right? All of those would be at rest from different starting positions. In general, and here's the big idea on a position versus time graph, is that the slope of the line represents the velocity of the object. So here, 0 slope means 0 velocity, right? That would mean it's at rest. Okay, so that's the first view